Okay, the last problem, we were worrying about volume of a sphere, right? Here's our sphere, kind of broken, right? But pretend it's a ball, and the volume is what is inside the ball, right? So if I take a look at these pyramids, right? The volume is what's inside, yeah? It's how much we have inside. But now we're going to talk about the surface area, which means what's on the outside. How much area do we have? So if I were to roof this, right? Does that look like a roof to somebody? Maybe? Of like a church? Right? Boom. Okay, so if I had a roof like this, how much material would I need? I'd have to have this. I'd have to have this. I'd have to have this and this piece, right? But we're going to even find out how much this is. Okay, so we're going to find out the surface area to all of it. To be able to do that, we have to piece by piece this prism out. But first we're going to talk about a circle. Okay, so the volume, right, is equal to 4/3 pi r cubed, right? But area, surface area is squared, isn't it? So thinking about the surface area of a circle is kind of weird, isn't it? Mm-hmm. And it's pretty advanced. I'm actually shocked that they're making you do it. So let's look up surface area of a circle.
According to sciencing, the formula for the area of that circle is A equals pi r squared. Substituting the known value of r into the equation gives you an equals. Pi equals pi. Substituting the accepted value of 3.14 for pi, you have an equals 4 times 3.14, or approximately 12.57.
Rapping.
Okay, so 4 pi. So the area of a circle is, the area of a circle is pi r squared, right? But the surface area of a sphere.
According to Harvey Mudd College Math Department, similarly, the volume of a ball enclosed by a sphere of radius r is 4/3 pi r cubed. And the formula for the surface area of a sphere of radius r is 4 pi r squared.
4 pi r squared. And that's the surface area of a sphere. Okay? That's not that bad, actually. That formula, not that hard. Okay? So what we're talking about, when we're talking about a sphere, so that's the definition of the surface area, right? SA, of a sphere. Okay? And in our sphere that we're talking about, we have 9 meters. Is your radius. So r equals 9. Okay? So when I plug that in, it's pretty simple. Area of a sphere is equal to 4 times pi times r, which is 9 squared. And that's substitution, right? And then what do we have to do first? We have to do our exponents, right? So our exponents, or simplification of exponents, would be, sorry, that looks like a sum. We want to do exponents. So our exponents would be what? 9 squared, right? Which is 9 times 9?
81.
81. So 4 pi 81. Now if I think of 4 81s, well, 4 times 8 is what?
32.
32. So that would be 320, right? Plus 4. So it would be 324. So the surface area of this sphere is equal to 324 pi. Okay? And then I take that 324 pi and I figure out, oops, I get 1017.87. So 1017.87, and the 7 does what to the 8? Makes the 8 go up or stay the same?
Up.
Good. So 1017.9, and we have to remember that this was meters, so it's meters squared, so we end up with meters squared. So we did the multiplication from left to right, and then we did the approximation. And remember, the approximate value looks like that. Alright, and there you go. And that should be number 26.
6.
And that'll take us to the bell. So have a good lunch.